Welcome to this section of this course. This integration was asked by MIT in the year 2020 and this is question number 3. We have log x over here and we have 1 upon x. So let's substitute log x equals to u, straightforward. So let's substitute u equals to log of x, then my du will be du equals to 1 by x dx. Therefore this dx upon x become my du. Let's change the limit when x tends to e. When x tends to e, log e is what? 1. Therefore u tends to 1. And then when x tends to e raised to e, then u tends, then log of e raised to e. So e raised to e I can bring down. So it's same as e into log e. So log e is 1, therefore it is equals to e. So therefore this integral, so e to e raised to e, limits become 1 to e. Here 1 to e. What is log x? Log x is u. U into log of log x is u into dx by x is du. Now from here we can use integration by parts, islet, or you can use tabular form or DI methods, anyone you can use. So I will use integration by parts. So by integration by parts we have islet rule. So we have logarithmic as well as algebraic. So I will choose this as a first function and this as a second function. So is similarly I will write one step over here, 1 to e log of u into u du is equals to, this is first function and this is second function. So keep as it is, log of u, integral of u is u square upon 2, limit is from 1 to e minus integral, differentiation of first function is 1 by u, and then integral of this second function is u square upon 2, and then du, and limit is from 1 to e. So e is equals to, now if I substitute upper limit, means here we have log of e is 1, e square upon 2, e square upon 2 minus, this is upper limit, minus lower limit. Well, lower limit over here, log 1 is 0. So everything become a 0. Okay. So this is upper limit and lower limit for this first term. Okay. Minus, here u and u gets cancelled. We have only one u. So this 1 by 2 I can send outside. 1 by 2 integral. We have u, limit is from 1 to e du is equals to e square upon 2 minus half, this integral is u square upon 2, and limit is from 1 to e is equals to e square upon 2 minus, here 2 to the 4, I will write 4 here, upper limit minus lower limit, upper limit means u square, instead of u, this is u, okay, instead of u we have to substitute 1 and e square minus 1, okay, 1 square is same as 1, so is equals to, so e square upon 4 minus plus 1 by 4. If I subtract these two, then take LCM, till LCM we have 4, 2e square minus e square plus 1 by 4, twice e square minus e square is, we have e square upon 4 plus 1 by 4. If I take 1 by 4 common, then e square plus 1. So this is the required answer for this. If you like this video, please like and subscribe. Thank you for your support. This question was asked by MIT Integration B qualifying exam in the year 2020 and this is question number 4. This integration looks easy as well as straightforward, but it might be somehow lengthy. Now we'll use the property of log of m by n. What is log property of m by n? Log of m upon n is same as log of m minus log of n, where m and n are greater than 0. Therefore, this is equals to, I can write integral 0 to 1 log of 1 plus x minus log of 1 minus x, and whole we have dx, and these are property which I'm using. Okay. Now what I will do is, from here you can separate this integral and then you can integrate it. Okay. But what I will do is, I will substitute 1 plus x as a sum u or 1 minus x as sum v, so that the terms will get somehow smaller. Okay. So for this term, so first of all I will separate this. This equals to integral 0 to 1 or log of 1 plus x dx minus integral 0 to 1 log of 1 minus x dx. Now here you can apply straight integration by parts by considering 1 is over here. Similarly also here we can consider 1 over here. Okay, but I will make some u substitutions and v substitutions so that these terms become somehow smaller. Okay, for this first part I will substitute u equals to 1 plus x, then my du equals to my dx. Okay, what about limits? When x tends to 0, then u tends to what? When x tends to 0, u become 1. Okay, as well as when x tends to 1, then when x tends to 1, 1 plus 1 is 2, u tends to 2. For this first one. Okay, and then for second one, let's I will substitute v equals to 1 minus x, then my dv equals to minus dx. So what about when x tends to 0, then v tends to, when x tends to 0, then v tends to 1. When x tends to 1, then v tends to 1 minus 1 become 0. Okay, log of this. Okay, this is as log of for first integral. Okay, this is for first and this is for second. Okay, so log of, we have log of u, and what is dx? Dx is become my du. And what about limits? Limit is from 0 to 1 to 1 to 2. Okay, 0 to 1 become 1 to 2 over here, and then minus, here we have dx is become minus dv. Okay, here you can write over here minus dv. So this minus become plus integral log of 1 minus x is v, and then dx is minus dv. This minus gets cancelled, dv, and then limit is from 0 to 1 become 1 to 0. Yeah, 1 to 0. So as I told you, let's consider 1 is over here, and let's use integration by parts. So I will consider log u as first function and 1 as second function. Similarly, log v as first function and 1 as second function. Okay, so is equals to, first function keep as it is, log of u, and integral of 1 du become u, limit is from 1 to 2, minus integral, differentiation of first function is 1 by u, integral of second function is u, and then du. Limit is from 1 to 2. Okay, this is for this. Okay, this is for this, and then plus, what about this? Okay, similarly here log v, this is for first function. Okay, log v, and then here integral of second is, you will get v over here, and limit is from 1 to 0, minus integral differentiation of first function means we will get 1 by v, and then into v, dv, and the limit is from 1 to 0 is equals to what we have, upper limit minus lower limit means 2 into log 2, okay, upper limit, minus here we have 1 into log 1, log 1 is 0, okay, so we have 0, and then minus, okay, and then this u and this u gets cancelled, we have integration of this is u, okay, so u and limit is from 1 to 2, okay, and this is for first term, and then plus, when I substitute if v equals to 0, everything becomes 0. When I substitute v equals to 1, log 1 is 0, okay, now everything becomes 0, so we have 0 minus, similarly here if I gets cancelled, we have only v, limit is from 1 to 0, okay. So we have 2 log 2, this 0, here upper limit minus lower limit means 2 minus 1 is 1, plus here plus 0, okay, so minus here 0, upper limit minus lower limit is 1 is equals to minus plus, okay, so this gets cancelled, we have 2 log 2, or you can bring this over here by law property of log of a raised to m is same as m into log of a, where m is greater than 0, okay. Now if I use this property, I can bring these two, so this become log of 2 square means log of 4, okay. So this is the required answer. Thank you for watching. Please like and subscribe. Thank you for your support. Welcome to the section of this course. This integration was asked by MIT 2020 Integration B, the qualifier exam. This is question number 11. We have integral root 2 upon 2. Instead of root 2 upon 2, you can consider 1 by root 2. Root 2 upon 2 to 1, sine inverse x upon x cube dx. This we can solve two ways. First way is directly we will apply integration by parts, considering sine inverse x as this as first function and 1 by x cube as a second function. And another way is you directly substitute u equals to sine inverse x, change the limit, convert everything in terms of u, and you will have some integral algebraic function as well as trigonometric functions. Okay. Then also you have to apply integration by parts. Okay. So their method also you can solve, but I will solve directly applying integration by parts. Now let's apply this integration by parts. This equals to integral. So I will consider sine inverse x as the first function. So sine inverse x. Now integral of 1 by x cube is same as x raised to minus 3, and this same as x raised to minus 3 plus 1 upon minus 3 plus 1 means x raised to minus 2 upon minus 2 means I can say it's minus 1 by 2x square. So integration of 1 by x cube is minus 1 by 2x square. So I can write minus this upon 2x square. Limit is from root 2 upon 2 to 1. Limits I will put later on, okay. So minus integral differentiation of sine inverse x is 1 upon root over 1 minus x square into integration of this second function is we have this, so minus 1 upon 2x square into dx. So this minus and minus become plus, so I can send these two outside, so I can write 1 upon 2. Now let's solve these integration parts. Over here, let's see, here we have square root of 1 minus x square. Now from here, if I want to take x square common, let's see, if I take x square common inside the bracket, x square common, then this become x raised to minus 2 minus 1. Okay. So now I can send this x square outside. This is same as x square. If I send outside, it become x square root of x raised to minus 2 minus 1. So instead of this, I can write like this. Okay. So instead of this, I can write like this. This is same as x into square root of x raised to minus 2 minus 1. And this x square and x, we have x cube over here. So let's solve this integral. This we already have. Okay. Now if I substitute u equals to x raised to minus 2 minus 1, then my du will be minus 2 x raised to minus 2 minus 1 is minus 3 and dx. Okay. So what this is same as, I can send du by, I can send here by 2 is same as 1 by x cube into dx. So what we have is 1 by x cube into dx is become minus du upon 2. Okay, this we have. And let's change the limit. When x tends to 1, let's say when x tends to 1, then u tends to, when x tends to 1, 1 minus 1 becomes 0, u tends to 0. When x tends to root 2 upon 2, then u tends to 2 minus 1 is 1. Okay, so therefore this integral is become, so integral of this integral become root 2 to 2 becomes, means it means 1 to 0. This is what, minus, I can send outside du upon minus 2 minus half, this minus half is there, and then square root of, this is square root of u. We have minus half integral of integral 1 to 0 u raised to minus half du. Let's integrate this, minus half u raised to minus half plus 1 is half upon 1 by 2. Okay, so these 2 and these 2 gets cancelled. So these 2 and these 2 gets cancelled. We have minus of u raised to half. What is u? U is this. So I can write square root of x raised to minus 2 minus 1. Okay, this is for this one. Okay, now let's substitute over here. Therefore this integral, this is equals to minus sine of inverse x upon 2x square minus what we have already half over here. Okay, so we already have over here, so this will be half square root of x raised to minus 2 minus 1, and limit is from here root 2 by 2 to 1. So I'll erase the rest of the things. Now let's substitute upper limit minus lower limit. Sine inverse 1 is pi by 2, so I'll have minus pi by 2 upon here 2 minus here 1 minus 1 is 0, so everything becomes 0 over here. Upper limit minus lower limit, root 2 by 2 is same as 1 by 2, sine inverse root 2 is 45 degree. Okay, minus pi by 4 upon 2 into 1 by root 2 the whole square, means these 2 gets cancelled, minus, so now if I substitute 1 by root 2 over here, so 2 minus 1 is equals to minus pi by 4, here minus minus plus, plus pi by 4 minus minus plus half. Okay, so 2 minus 1 is 1, so these 2 gets cancelled, so we have only half. It is the required answer. Welcome back. This question was asked by MIT Integration Qualifier exam in the year 2020, and this is question number 12. Now here what I'm going to do is I'm going to use the formula for sine twice theta or sine twice x, and then after that I'm going to substitute u equals to cos x. Let's see. And we have, remember, sine of 2x is equals to 2 sine of x into cos x. If it is sine 2x, we have sine x as well as cos x. So I'm going to use this over here. This equals to integral 0 to pi by 2. This same as 2 sine x into cos x into, okay, and we have cos of cos x dx. Now let's substitute cos x equals to u. So I will substitute u equals to cos x, then my du is differentiation of cos is minus sine of x dx. So we have sine x as well as dx. So I will send this minus this side. So my du equals to minus du equals to sine of x into dx. Sine of x into dx become my minus du. So what about limits? When x tends to 0, okay, when x tends to 0, then u tends to cos 0 is 1. When x tends to pi by 2, then u tends to cos pi by 2 is 0. Okay, here we have 0. This is equals to 0 to pi by 2 become 1 to 0. 1 to 0. And then I will send these two outside, and then sine of x into dx is minus du. Minus, I will write here du, and cos x is, we have u into cos of cos x is u into du we have, okay. Here this minus, okay, I will remove by interchanging by 0 to 1 u into cos of u du. Let's apply integration by parts, islet or tabular from our DI methods. Let's apply integration by parts, okay. Here we have 2, we have islet rule. Let's take this algebraic first, okay. Now let's consider this is first function and this is second function. U as it is, okay, integration of cos is sine. Yeah, we have sine of u, and then limit is from 0 to 1 minus integral differentiation of u is 1, and then integration of cos is sine of u, and limit is from 0 to 1, okay, and then du is equals to 2, and then we have upper limit minus lower limit, okay. Here 1 into sine 1 is sine of 1 minus also 0, everything becomes 0, minus 0, okay, minus integration of sine is minus cos, so minus plus cos of limit is from 0 to 1 is equals to twice we have sine 1 plus cos of 1 minus cos of 0. Cos 0 is 1, okay. Here we have 1. So this is the required answer for this, okay. Thank you for watching. Please like and subscribe. Thank you for your support. Welcome back. This integration was asked by MIT in the year 2022, and this is question number 10. Let's expand this, okay. So if I expand this become integral 0 to 1 e raised to x minus, this is same as e raised to x into e raised to minus x. Why? Because if I add these two, if base are equal, I can add the indices, okay. So this is my dx. What is u into v differentiation, okay, means product rule of differentiation is what? Is equals to u v dash plus v u dash. Let's see if I differentiate this, what comes, okay. Now if I differentiate this, let's see d, what is d by dx of e raised to x into e raised to minus x. This equals to, now let's apply u into v rule. Now let's keep this as it is, e raised to differentiate this, e raised to minus x into d by dx of minus x is what? Minus 1. So I am writing minus over here, okay, plus, so let's keep e raised to minus x as it is, and let's differentiate this, e raised to e raised to x, differentiation of e raised to x is e raised to x itself. Again, let's differentiate this. So this will be as it is, e raised to x. Now these two gets cancelled. Okay, e raised to minus x plus x gets cancelled. What we have is I can write this first, e raised to x, this second minus e raised to x, and then e raised to minus x. Okay, now this is what, this is same as this. Look at here, this is same as this. Therefore, if I substitute u equals to whole this, e raised to x into e raised to minus x, then my du will be this e raised to x minus e raised to x e raised to minus x into what, dx. Okay, so therefore whole this become what, my du. Okay, so for whole this is what, this is my du. Okay, so whole this become my du, this is what, this is dx. So let's change the limit. Okay, so when x tends to 0, this become 1, as well as e raised to 0 is 1, therefore we'll have only e raised to 1. Okay, now u tends to this. Okay, when x tends to 1, what about u tends to what, x tends to 1, then e raised to minus 1, e raised to e, e raised to minus 1. This integration is become u, and then upper limit minus lower limit, e raised to e, then e raised to minus 1 is equals to e raised to e minus 1 minus e. Okay, so this is the required answer. Welcome to this section of this course. This integral was asked by MIT 2020, question number 13. This can be solved many ways. Here limit is from 0 to 2 pi, so we can convert 0 to 2 pi to 0 to pi and pi to 2 pi, and we can find this area also. Otherwise, what we can do is we can solve this by expanding. You consider this is a and this is considered b by applying sine a minus b. We have sine of a minus b, formula is same as sine a cos b. If it is minus, then minus, then cos a sine b. Okay, now let's apply this formula. This equals to 0 to 2 pi sine of, you consider this is a and this consider this is b. Okay, sine of a means sine of sine x, then cos of b means cos of x. If it is minus, then minus. Cos of a means cos of sine x, then sine b. Sine of b means x. Here we have dx. Now here let's substitute u equals to pi minus x, then my du equals to minus dx. What about limits? When x tends to 0, then u tends to, when x tends to 0, u tends to pi. When x tends to 2 pi, then u tends to, x tends to 2 pi, then u tends to minus pi. Okay, so therefore this integral become 0 to 2 pi become pi to minus pi, and then here we have sine of x. X is, from here we can find x. From here x equals to, if I send this is pi minus u. Here this is sine of pi minus u, and then cos of pi minus u minus cos of sine of pi minus u, and then sine of pi minus u. And what is dx? Dx is minus du. So this is minus du. This minus I will change by changing limits from minus pi to pi. Okay. What is sine pi? Here we have, here this, from here to here is pi. Okay. Here this is in second quadrant, sine is positive over here. Okay. Therefore sine of pi minus u become, since it is multiple pi, sine will go to sine and it will be plus because it is in second quadrant. Cos of pi minus u, cos of pi minus u is here, cos of pi minus u is in second quadrant, so cos will go to cos, but it will be minus. Okay, so instead of sine pi minus u, I can write sine u. Okay, here I can write only sine of u, and then cos of pi minus u, I can write cos u, as well as we have cos of minus u same as cos u because it is even function. So instead of cos of pi minus u is minus cos u. Okay, and then cos of minus u is cos u. So I write only cos of u. Similarly, sine of pi minus u is what? Sine u. And then sine of pi, here also sine of pi minus u is sine u. Now we have concept of even and odd function. Okay, what is even function? What is odd function? Now even function means if f of minus x equals to f of x, then it is even function. For example, even function means cos of minus theta is same as cos of theta here. Okay, and then what about odd function? Odd function means if f of minus x equals to minus f of x. So, for example, sine of minus theta equals to minus sine theta. Okay. And this is odd function, we call odd, and this is even function. Okay. And then we have formula integral of minus a to a f of x dx equals to 0. This is 0 when f of x is odd function. Okay, when this fx, okay, is odd function. Okay, we substituted instead of u minus u. Here will be what? Here will be cos of minus u will be cos of u, doesn't affect anything. What about here? Okay, here will minus come outside. Okay, sine of minus theta is minus theta. Therefore, this also odd function. Now, what about here? Here we will get minus over here. Okay, sine of minus u means sine of minus u will get minus outside, but since cos is there, even function. Okay, therefore plus minus here will get this. Therefore this also odd function. Okay, so integral minus pi to pi odd function, whole this integration become 0. Okay, this question was asked by MIT 2020, question number 15. After looking this integral, we should apply King's formula. Let's convert tan is same as sine by cos, and let's consider I equals to this 0 to pi by 2. Let's consider the I equals to, let's say I equals to this. Here tan is same as sine by cos. So we have sine of square root of 2020 upon cos of this 2020 x1. Okay. Now let's take LCM. If I take LCM and let's sum up, here we will get cos of square root of 2020 x. Here we will get sine of this plus cos of square root of 2020 into x dx. By King's principle, u equals to pi by 2 minus x. What is du? du is minus dx. What about limits? When x tends to 0, x tends to 0, u tends to pi by 2. When x tends to pi by 2, then u tends to 0. So 0 to pi by 2 become pi by 2 to 0. We have I, okay, and this cos of, what we get? Cos of square root of 2020. Instead of x, we have to write what is x? Pi by 2 minus u. So cos of pi by 2 minus u upon sine of 2020 instead of x, pi by 2 minus u plus cos of 2020 pi by 2 minus u. Instead of dx, what we have to write? Minus du. Okay, so du, this minus I will change limits from 0 to pi by 2. Okay, now cos of pi by 2 minus theta, what is this? cos of pi by 2 minus theta. Here we have pi by 2, 0. Pi by 2 minus theta is in first quadrant. Here all are positive. Plus over here, cos will go to sine of theta. Similarly, sine of pi by 2 minus theta sine will go to cos theta with plus sine. So, what we have 0 to pi by 2. Cos of pi by 2 minus theta minus u become sine of square root of 20 u. This become cos, this becomes sine. Cos of 20 u plus sine of 20 u into du. Okay. Now this we have integral 1. We have this integral. We have 1. Okay. This integral is I. This integral is I. We have integral of a to b f of x dx equals to integral of a to b f of y dy. Okay. We choose any variable. This is same as a to b f of say f of t dt. Okay. So now if I consider, therefore I can consider this as t, or you can say here t, here t dt. Here also if I consider t over here, t over here, t over here dt, the value of integration will be same. Now if I add these two, let's say if I add this I and this I, what will get on the left hand side? I will get twice I. On the left hand side I will get twice I is equals to integral 0 to pi by 2, 0 to pi by 2. Here denominators are same. Okay, denominators are same. We have sine of square root of 20 t plus cos of square root of 20 t dt. We have sine plus cos. Sine of square root of 20 t plus cos of square root of 20 t. Okay. Now this and this are same, gets cancelled. What we have? Integral dt. Okay. Integral dt. We have it's only t. Limit is from 0 to pi by 2. Therefore we have only pi by 2. So on the left hand side we have twice I. Therefore I equals to pi by 4. Okay. This is the recurrence. Welcome back. This integration was asked by MIT Qualifier exam in the year 2020, and this is question number 19. This integration can be solved many ways. There are few minutes to solve. I will solve very quickly first method, and second method I will solve by substitutions. If I consider y equals to square root of 1 minus x square. Now if I do squaring on both sides, what I will get? Y square equals to 1 minus x square is implies x square plus y square equals to 1. What is this? Remember, this is what? This is equation of circle having center what? 0, 0. Why? Because we have x minus 0 the whole square plus y minus 0 the whole square equals to 1. Means center at 0, 0, and radius is, this is center, and radius is 1. Okay. So it means what? It means this is this is x-axis O x dash, y O y dash. We have circle over here. We have circle, center at 0, 0, and then radius is what? Radius is 1. Means what? This 1, 0. Okay. Here 1, 0 as well as 0, 1 satisfies over here. Okay. When you substitute y equals to 0, you will get x equals to 1. Okay. So it means what? This is the upper right top corner, the area of circle at first quadrant. X equals to 0 to what? X equals to 1. We know area of circle is what? Area of circle is pi r square. This is what? Area of circle. Okay. And we have r is what? Radius is 1. So we have only pi. But this is what? This is quarter. Okay. Quarter of the circle. Therefore, the area of this will be pi by 4. Okay. Therefore, the value of this integral is pi by 4. So pi by 4 we are getting very quick answer. Another way I will solve by substitution. So x equals to sine u. X equals to sine of u. We know sine square u plus cos square u equals to 1. Okay. 1 minus sine square u is equals to cos square u. Okay. So now if I take square root on one side, 1 minus sine square u equals to cos of u. Okay. It means root of 1 minus x square become cos of u. Okay. Therefore, instead of this, I can write cos of u. What about dx? Dx differentiation of this is differentiation of sine is cos of u into du. Limit when x tends to 0. When x tends to 0, u should be 0. Okay. When x tends to 0, u should be 0. Sine 0 is 0. When x tends to 1, then u should be pi by 90 degree, pi by 2. Okay. So therefore this is become 0 to 1 to 0 become 0 to pi by 2. Square root of 1 minus x square become cos of u. We have cos of u into what is dx? Dx is again we have cos u into du. So is equals to we have is equals to integral 0 to pi by 2. We have cos square u into du. Now again here I will use Willis theorem. Okay. So by using Willis theorem, what we can say is equals to we have here 2. Okay. So the indices is 2, decrease 1 means 1. We have to stop over here. Upon we have 2 over here. Okay. And since it is even function, even over here 2 is, we have to multiply by pi by 2. Okay. Means pi by 2 to the 4 is the required answer for this. Okay. Now here I am applying what? By Willis theorem. By Willis theorem. Otherwise, what we can do is, we have cos square is what? We have 0 to pi by 2. Cos square is 1 plus cos of 2u upon 2 into du. Okay. This we have. Why? From here we have, because cos of 2u is same as cos square u minus sine square u. And this is same as 2 cos square u minus 1. We have cos of 2u. From here you can find 2 cos square u is same as 1 plus cos of 2u upon 2 is same as cos square u. This I am using over here. And then if you integrate this, we have u plus integration of cos is sine twice u upon differentiation of twice u is 2. And then you substitute 0 to pi by 2. Similarly, you will get this answer pi by 4 also. Another method is, for this, what you can do is, you can apply, we have integral of square root of a square minus x square. We have formula this. Okay. By applying this formula also, you will get answer at one line. Okay. Anyway, you will get the answer is pi by 4. Okay. Thank you for watching. Please like and share. Thank you for your support. Integration by parts. Okay. For that, I will substitute u equals to, I will try to decrease. Okay, u equals to x square. Okay. If I do, then my u square becomes, if squaring on both sides, x raised to 4. Okay. And then if I differentiate this, du become twice x dx. Okay. So therefore, here du upon 2 equals to x into dx. Therefore, what about limits? Okay. When x tends to 0, u also tends to 0. When x tends to infinity, so u tends to infinity. Limit doesn't change anything. Here we have 0 to infinity as it is. So instead of x5, I can write x into x4 and then e raised to minus x4 dx is equals to 0 to infinity. Now what I can do is x into dx. Okay, x into dx is du upon 2. Okay, so I will write upon 2 means half I'll write over here du. Now x raised to 4 is u square, and then e raised to minus x raised to 4, okay, minus x raised to 4 is u square. Here I will use integration by parts, or you can say tabular methods or DI methods, okay. Now instead of this, let's consider this part, okay. Let's consider this very carefully. Let's apply here DI methods, the differentiation integral over here. Now this, if I separate u square as u and u into e raised to minus u square, okay. U into u is means what? What I am doing is, this is same as u into u e raised to minus u square, okay. What I am doing is, here we have minus e raised to minus u square, okay. Now check over here, okay, what is differentiation of e raised to minus e square, okay. If I differentiate this, what comes, okay, this is same as e raised to minus e square divided, differentiation of e square is minus twice u, okay. We already have u over here, okay. So I need, what is, I need minus 2, okay. Minus 2 means what? This term I should consider as minus 2 this, okay. So in order to get this, we already have u over here, okay. So we should have minus 1 by 4. So that this into this should get u square into e raised to minus u square. So this part I can write in differentiation part, and this part I can write in integration part, okay. So this I can minus 1 by 4 u, okay. Differentiation of this is minus 1 by 4. Therefore this integral is same as this into this, okay. Here minus 1 by 4 u into this, okay, into e raised to minus u square, okay, this into this with plus sign and minus sign with this into this, okay. Integral in minus integral minus minus plus, we have 1 by 4 e raised to minus u square 0 to infinity du, okay. So is equals to, okay, when limit from 0 to infinity, this whole term becomes 0, okay. And then what about this, okay, this is what? Root pi by 2, okay. But we have 1 by 4, 1 by 4 into root pi by 2 is root pi upon 4 to the 8, okay. This is the required answer for this.